Hello there guys, welcome back to another epic and extra maths video. In this video we're looking at the t-formulae, the tangent half angle formulae, and we're trying to solve this trig equation for values of theta between 0 and 2 pi. These are the t-formulae or the tangent half angle formulae. So, by the way, link in the description to the playlist on the t-formulae, link in the description to the last video I made on the t-formulae, the very first one. This is the second t-formulae video, okay, where I explain what it is, where these formulas come from, okay? But now we're gonna do another example. We did an example in the last video, we're gonna do a slightly harder one in this video, okay? And there's gonna be more to come. But just to recap that video if you can't be bothered to watch it, which is fine. Basically, the t-formulae is a way to turn trig equations into algebraic equations, because it turns out you can actually express every trig function just in terms of tan, which is pretty cool. So tan, we call it t, and sine theta, cos theta, and tan theta, they can all be expressed in terms of tan of theta over 2, which we call t. Okay, let's just go straight into this, guys. So you might say, hold on, what do we replace cot and cosec with? Because none of them are there. But remember, cot is 1 over tan, and cosec is 1 over sine, so we can replace each of these trig functions with their reciprocal over there. So, first line, we can say that 7 times what is cot? Well, cot is 1 over tan, so in other words, reciprocal of the tan t formula, 1 minus t squared over 2t, plus 3 times cosec. Again, cosec is 1 over sine, so 1 plus t squared over 2t equals 9. Okay, now it's an algebraic equation. It used to be a trig equation, now it's an algebraic equation. Isn't that awesome? Yes, it is. So I'm going to times both sides by 2t, and I'm going to clear it up, guys, because I know that we can do this in one go. We don't need to do 2 steps for this. Let's not waste anyone's time here. So I'm timesing both sides by 2t, and I'm expanding the brackets out. Okay, simplifying further, we have minus 4t squared plus 10 equals 18t. And then moving everything onto the same side, we have 4t squared plus 18t minus 10 equals 0. Okay, I'm just going to half both sides just to make the numbers a bit smaller. Not essential. And then I'm going to notice that this actually can factorize as follows, but you could use the quadratic formula. This is a quadratic. You could use the quadratic formula if you wanted to, but I'm just going to notice, as I say, that this is going to factorize as follows. Minus 1 there. And I'm going to get 2t minus 1 times t plus 5 equals 0. So that tells me that t would have to be either 1/2 or minus 5. Okay, hopefully that makes sense. Now remember, t is tan of theta over 2. So that means that tan of theta over 2 is 1/2, or tan of theta over 2 is minus 5. Okay? So now we once again have some trig equations, but do you see that we turned it into an algebraic equation, did all the hard stuff, and then just turned it back into trig pretty much at the end? It's pretty cool, right? Okay, so using the first equation, tan of theta over 2, let's get all of the values of theta out of this that we possibly can. So first of all, let's just inverse tan both sides of this equation to get theta over 2 equals arctan, or inverse tan, of 1/2, which ends up being 0.46368, roughly. Okay, just give it, it's always good to give it a few decimal places, right? Okay, cool. Now, we could also times both sides of this by 2 if we wanted to. It depends exactly how you want to do this and what your personal preference is to solve trig equations. Remember guys, with tan, you can keep adding multiples of pi to the solution and it will still be a solution, right? So actually, before I double it, let me do that, okay? Because if you can't double it and then add pi, that won't work. You have to start adding or taking away pi immediately. So I'm going to do that value plus pi right now. Okay, so another value of theta over 2 would be 3.60524, okay? And then I'm noticing, because I'm going to have to double these, will I be able to get any more values? Well, no. I mean, this one isn't even a value anyway, is it, guys? Because if we double this, this will give us a value bigger than 2 pi, because 3.6 is bigger than pi. So this one won't even be an answer, but that's fine. And is there any other way to get an answer out of this? No, there's not, okay? So the only actual answer from tan theta equals a half, I'm going to write this down here, the only actual answer is going to be double this first one. So 0.463648 times 2. We've got theta equals 0.927296. And obviously you can leave that to as many decimal places as you want. Then we have tan theta equals minus 5. So let's do this one here. So that means that theta over 2, I should have said tan of theta over 2 equals minus 5. I think I said tan theta equals minus 5. Tan of theta over 2 equals minus 5. So inverse tan both sides of that one. Inverse tan of minus 5, we have minus 1.3734, roughly, okay? And again, what we can do to that one is we can add pi, because clearly this won't be a solution, right? Again, we're going to have to double it to get theta, but this is negative, so it's definitely not a solution. We can add pi to it, though, to get that theta over 2 can also be equal to 1.76819, and then if we added another pi to that and then doubled it, it would definitely be bigger than 2 pi, so we don't really need to do that. And then just using this, the other answer, actually I'm going to do it over here for you guys, is just double this, okay? So timesing that by 2, we have 3.536. So 3.53638, etc. But I'll just do a 4 there. So these two answers are, we believe, the only two answers to the trig equation that we've done here. Those should be the two answers. Now, as always, guys, I mentioned it last time, but it's good to make a habit out of this. If an odd multiple of pi is a solution to the trig equation, using the t-formulae will not give you that as an answer. It will miss the answer out, and that's because tan of theta over 2 is undefined when theta is an odd multiple of pi. Okay, so tan of, for example, pi over 2, undefined. Tan of 3 pi over 2, undefined. Tan of minus pi over 2, undefined. So whether or not it's positive or negative, an odd multiple of pi for theta, you're not going to get an answer. So quickly, we need to just check that theta, the only odd multiple of pi between 0 and 2 pi is just pi. So we just need to check that theta isn't pi, because that could be a third answer hypothetically. And by looking at the original equation, we know for a fact that theta cannot be pi because cosec of pi is undefined, okay? And that's because, again, cosec is 1 over sine, and sine of pi is 0, so cosec of pi is like 1 divided by 0, undefined. So we know that pi isn't an answer, okay? So those are the only two answers, and now we know that for sure. As always, guys, thank you so much for watching. There'll be more videos on using the t-formulae coming at you very soon. So stay tuned for those, and I'll see you in the next one. Cheers.